Hey, what's up everyone? In this lesson, we'll be covering the Hackerrank medium rated question algorithm non-divisible subset. So this question's a little tough, but don't worry, we will dive in and go through the logic step by step. So we are given an array S and a divisor K. And this question wants us to find the longest subset array in which no two numbers, the sum of no two numbers in that subset are divisible by K. Kind of funky to wrap your brain around. But so in this first example scenario, they provide that there are two subset arrays that have a maximum length of 3. So let's do some quick math. What is 10 plus 12? 10 plus 12 is 22. Is 22 evenly divisible by 4? No. So that's perfect. Those two numbers check out. 10 plus 25. What's 10 plus 25? 10 plus 25 is 35. Is that divisible by 4? No. Those two check out. Last combination would simply be 12 and 25. What's 12 plus 25? 37. Is 37 divisible by 4? No. So those check out. Same scenario for our S quote 1 array here. So hopefully you're understanding what we're looking for, and hopefully you're starting to think about how we can solve this question. The simple way to solve this question would be to build out all the possible subarrays and then loop through those subarrays and ensure that the sum of any two numbers in that subarray is not divisible by 4. And then any subarray that would satisfy that condition, you would compare the maximum lengths of those subarrays and provide an answer for the longest subset array. So a couple steps, but it should be fairly intuitive if you think about it for a little while. But of course, with most of these Hackerrank algorithms, that runtime is going to be too long, and you're going to get a runtime error. So we know that that won't work. You could type out all the code and figure it out, and sure, you would get it in a couple scenarios, maybe, but eventually you would get a runtime error. So let's head over to Replit and start thinking through some other logic that would cut down on the amount of computing power that we would use to solve this problem. So we've copied over this fairly long subset, or sorry, this fairly long S array. There we go. And we're working with a divisor of 6. So really, to figure this out, we need to apply some different logic. So if you start doing some math, you start playing with these numbers, you'll realize that really all that matters is the number's remainder when it is divided by 6. So 12 divided by 6, its remainder is 0. 6 divided by 6, its remainder is 0. And we can treat them as like numbers. We could treat them as like numbers. 1 divided by 6, now we're going to speak in modulos. So 1 divided by 6, the remainder is 1. 9 divided by 6, remainder is 3. So we would treat those as different categories. 1 would be added to the category of remainder 1. 9 would be added to the category of remainder 3. And let's just pick 10. 10 would be added to the category of remainder 4, and so on and so forth. We want to treat these items in our array as the category of remainder that they have when divided by our divisor of 6. Okay, so when considering these numbers by their remainders, what scenarios would we want to avoid having in our subarray? Well, if we have a subset, if we have in our subarray something that has the remainder of 0, we don't want more than one of those in our subarray, right? So if we had 6 and 12 in our subarray, and we did the math of 6 plus 12, well, that's also divisible by 6, our k. And what's the rule? We don't want any two numbers in our subset array when their sum is divided by our k, we don't want that to be divisible. So anytime we have the category of 0, the remainder of 0, we could really only pluck one of those numbers, because if we have two of those numbers in our subset array, then we're going to get the non-desirable outcome of adding those two together and having their sum being divisible by 6. So that would be our first consideration. That is what you would see here in line 6. But we also have scenarios where the remainders are equal. When you add up the two remainders, those are divisible by k. So you could get the 0 scenario that we want to avoid, which would be something like 18 when you add 12 and 6. Or you could do something like 1 and 5. So our remainders of 1 and 5, or conversely 5 and 1, what is the sum of those remainders? Well, that's k. It is 6. So you'd want to avoid those scenarios as well. So for k of 6, what might those be? We can go down here and take a look at those. If p plus q is equal to 0, you would only want to take one of those, or if that never occurs, you would not take any. For the remainders of 1 and 5, you would want to take the maximum, which I'll dive into in a minute. Same for 2 and 4, and then here's our 3 and 3 scenario, which I'll also dive into in a minute. Okay, great. So those are most of our cases. Well, actually, those are all of our cases. Most of our cases will be these here, these 3 lines, excluding our unique case here. Okay, so what would we do for these cases? Well, we would want to take the occurrence that happens the higher number of times. So say we have remainder 5, and we have tons of remainder 5s in our array. We would want to select that one if our remainder 1 happened much less. So of these two remainders, we can only pick one, right? We can never have both of them in the array, in the subset array, at the same time, because then we wind up with the sum of our two numbers being divisible by 6. So we would want to take the one that occurs most, because we're looking for the longest subset array, right? So if there were a ton of numbers in our array that had remainder 5, well, we'd want to keep adding those to our subset array, because that gives us the most desirable outcome. Same with 2 and 4. But when you look at P and Q, we kind of already went over this. If P and Q, the sum of those remainders is equal to 0, well, you would just want to take one. Because if you had multiple of those in your subset array, well, then when you add those remainders together, when you add those items together, you wind up with a number that's divisible by 6, and you're trying to avoid that. But you can take one, because if you take one of those and you add any other number in the subset array, you're not going to get a number that is divisible by 0. Divisible by 6. Divisible by 6. Okay, so that leaves one last unique scenario, and it only occurs when k is even. So when you take k, if k is 6, we can wind up in a scenario where p and q are both equal to half of k. So what would half of k be equal to? Half of k would be equal to 3, remainder 3. And similar to the 0 scenario, we can have one of those, but we can never have more than one of those. Of course, there's scenarios where we will have none of those, where the array has no numbers that have remainder 3. But we can pluck one of them if there is one or more than one. If there are more than one, we do not want to pluck multiple of them, because then if you add those two numbers together, if you add them to the subset array, you would have to add all the numbers in the subset array to each other, and you would wind up in a scenario where you get 3 plus 3. 3 plus 3 is 6. 6 is divisible by 6, and you have broken the rule. Okay, so that should be all of our scenarios. I know I went through them a little quick, a little fast, but take the time to pause the video. Oh, we don't want a dictionary. Take the time to pause the video, copy all of this into your Replit, maybe write it down on a sheet of paper. Think about each line as you're writing it, but essentially you will start to learn, you will start to get these scenarios and the scenarios that are not possible or not desired. Okay, so that's half the battle, right? That is half of solving the algorithm. We have the logic. Now, how do we start to actually keep track of these remainders and then add the scenarios, add the items to our subarray, and get the answer that we want, the longest possible subarray? Well, we would start by creating a count array, and the count array will hold the number of times each remainder occurs in our array S. Maybe hearing that doesn't make sense, but once I write this code, I'm sure you will understand that, okay, we will create an array, and every time we have a number 2k, basically every remainder that is possible when a number is divided by k, we will create a counter for that. And I'll go ahead and show you. We'll print count now. What is count? So count is an array with 6 0 values in it. And so what do these represent? Well, this first one will represent index 0. Index 0 will be what in this scenario? It will be the numbers that are divisible when divided by k have a remainder of 0. And what's here? Index 1. What will this represent? Well, this will represent any time we take a number in our array, divide by 6, and have a remainder of 1. Same for this guy. What's this one? This is index position 2. Anytime we take a number in our array and divide by k, when we divide by 6, and have a remainder 2, that will represent those numbers. Okay, so what do we do now? Well, we need to populate our counter array. And how would we populate it? Well, we're going to loop through our S array, of course, because that's where all of our values are held. And we'll want to modulo k, we'll want to divide by k and find the remainders. And then each time we encounter a remainder that we're tracking, we'll want to add one to that position in our array. So to write that programmatically, we would do a for loop for our num in S. And hopefully, if you're doing a medium rated Hackerrank problem, you understand that that represents each number in our array of S. And we can define a variable. This part isn't really necessary. It's just good for clarity. We can define a variable of remainder equal to num modulo k. So for each num in our array, we will take that number and modulo k it, basically find our remainder. And then we can go to count at that position, at the position of the remainder that we just found. And we can add 1 to it. Plus equals 1. Okay, it seems like I'm missing something. Remainder is spelt incorrectly. That should fix it, I believe. Removing that random E would fix it. Okay, awesome. So let's go ahead and again print count at this point in our algorithm and see what we get. Okay, awesome. So what's happening here? How many, this is providing us with the answers to how many there are of each remainder. How many times do we want to run into a remainder of 0 when dividing the numbers by our k? Well, we just went through it. For remainder 0, we have both 12 and we have both and 6. We have no other numbers in our array that are evenly divisible by 6 straight up. How many times do we get a remainder of 1? We have that happen 3 times. We have it happen for 1, probably 13, and probably 19. Yeah, those should be our 3 for that. And then this counts the numbers with remainder 2, counts the numbers with remainder 3, counts the numbers with remainder 1, 5 and 4. 4 counts the numbers with remainder 4. This is index position 4, and counts the numbers with the remainder 5, index position 5. Okay, great. So we have the counter that we want. Now we start to apply all of this logic. Okay, so let's start with our unique scenario. We could really do this at any point, but let's start with our scenario 0. Let's work through our array in order. So what's the first value that we're going to consider? We're going to consider the remainder 0. And what happens when we have a remainder 0? Well, we follow this rule. Take 1 unless there are none. So we'll create an answer variable, and the answer variable, we will start to keep track with that condition. And what is the condition? Well, count 0 is the condition. And what did I say? We want to take the minimum in the range of count 0 to 1. And what does that mean? So if we have count 0 is equal to 0, meaning we have no numbers that when divided by k have a remainder of 0, we will want to take 0 and add that to our answer. But if we have a scenario where we have one of those or more, we want to only add 1 to our answer. And go back to that logic that we previously stated. You could have 6 and 18, but you never want to have both 6 and 18 in our subset array, because 6 plus 18 is divisible by 6. So let's say we picked the 18. We could pick the 18, or we could pick the 6, but we could never pick more than one number that has 0 as the remainder. So what are our options here? Well, you could have 0. We could have a value of 0 for count 0, meaning this number would be 0. We could have 1, meaning you could have 6 in the array, or you could have more than 1. 6, 18, 24. But we only would pick 1. So that's what we're representing in this min of that range. Okay, so let's go ahead and print answer. And what's happening here? We're getting 1. Because we know that there are multiple remainders of 0, but we only want to pluck one of them and add it to our answer array. Okay, awesome. So we have taken care of this scenario. What should we do next? Well, we can write an if statement to get this scenario out of the way. And what would the if statement be? Well, we know that this only happens under these conditions when k is even. So how would we represent that? If k divided by, not divided by, if k modulo 2 equals 0. That means that k is even, of course. Okay, and what would we do in this scenario? Well, similarly to this zero remainder scenario, we want to take the minimum, again, from the count to 1. Really follows the same rules. So we can do answer plus equals min count, and where would the count be? What position in our count array do we need to evaluate? Well, we need to evaluate k divided by 2. And you want to use, in Python, the 2 divisor signs, so we're evaluating it as an integer, not a float. And our range would be to 1 again. So here you could have the count being equal to 0, you could have none, you could have the count being equal to 1, in which case our answer would be go up by 1, because what's the minimum in the range from 1 to 1? Well, the minimum in the range from 1 to 1 is 0. And then, of course, you could go over the count. You could go over 1, where there could be 10 counts in our array. But at most, you would include only one of them in our subset array. So answer will only go up by 1. Okay, and finally, we'll want to do a loop that takes care of these scenarios. Well, we'll talk about this guy in a second. But so you may be thinking that you would want to loop through all of our numbers. You may be thinking that you'd want to loop through 1, 2, 3, 4, and 5. But that's not actually the case, because we can loop through just this first side and actually evaluate both sides. And what do I mean by that? Okay, let's go down and start writing our loop. For I in range 1 to k divided by 2 plus 1. Well, what have we just done? We've only evaluated half, essentially the first half of our combinations. And we'll have to throw in another line here. If I bang equals k plus 1. And we'll go through that line of code in a second. But first, we will explain why we only need to evaluate the first half, or we only need to loop through the first half of our range. Okay, so we'll do answer, and we'll plus equals the maximum of our counter I and our counter k minus I. Why can we do this? Well, we can do this because what would I be? Our I would be 1. And we want to take the max. In the scenarios where we have 1 and we have 5, we want to take the maximum of those two. Well, we can evaluate that. I need to write count. We can evaluate that by taking count of I and count of k minus, that's not supposed to be 1. I apologize. That might not make sense. Now it should make sense. Okay, so we only want to take the maximum of these two values. They are reciprocals of each other in terms to how far they are away from k. So k minus I. What's k minus I? Well, that's 5. And we only want to take the maximum of those two occurrences. If 1 occurs more times than 5, we want to add to our subset array the occurrences of 1. If 5 occurs more than 1, we want to add to our subset array the occurrences of 5. We never want both. We want to take the one that occurs more. So that will suffice for these two. First, you'll go through 1. Next, you'll go through 2. 2 will consider the remainders of 2 and the remainders of 4 and take the maximum, the one that occurs the most, and add those to our subset array. And then we run into this. And this will only happen when k is even. So I bang equals k plus, oh, I did it again. I'm so sorry. I keep writing ones instead of i's. Okay, I bang equals k plus I. What would this mean? This would mean that I is equal to I, or I is equal to k plus I. I know it's confusing, but this is that scenario. And the reason we want to exclude this is because we've already accounted for it. We've already accounted for it here. It will never occur in an odd scenario, and in an even scenario, which we indicated here, it will never occur. Okay, so we will go ahead and print our, what do we need to print? Well, we need to print our answer. And our answer should be 8, unless I've done something wrong. And we get 11. I think it's supposed to be minus. I think that's an issue with my logic there. Yeah, I'm sorry. I realized that while I was covering it. Something didn't make sense. Okay, so what is k minus I? Well, if I was 3 and we know k is 6, that is, I is equal to k minus I. You wind up with p and q both being 3. Okay, I hope that makes sense. If not, like I said, transpose all of this over to your replit, take the time to write it out. If it's still not clicking, take the time to write it in a notebook. I really suggest doing a notebook first. It might save you some time actually. So just go ahead and transpose that over to a notebook. We'll now copy and paste our code over to replit, run our sample test cases. Oh, what do we have? Oh, that's the issue. We need to return. Okay, that should suffice. There you go. We get both of our sample test cases, and now we'll run the code against all of our test cases, and hopefully they all come out green. Perfect, they all come out green. All right, well, thank you for watching, everyone. I know this one's a little tough, so take the time to really think your way through it. If you have any questions, please feel free to pop them down in the comments below. If you enjoyed this video, please go ahead and hit the like button. We post these all the time, so if you're working on algorithms, if you're studying for interviews, go ahead and hit the subscribe button, and hope to see you in the next one. Thanks for watching.